Okay, solving equations. This first example, 2x plus 10 over 3 equals 20. We want to solve for the value of x. The biggest challenge that we're faced with so far is the fact that this is a fraction. We want to do something about this 3. Get rid of this 3 out of the denominator, make it a little bit easier for us. So the easiest way to go about doing this is to take the entire left-hand side of the equation and multiply it by 3. By doing so, these two can cancel out and we won't have the denominator anymore. So we'll multiply both sides by 3 on this side to get rid of the denominator, and on this side just to keep the equation equal. The 3's cancel out on the left-hand side, and then we're left with 2x plus 10 equals 60. We want to isolate x on the left-hand side. To do so, we'll take that 2x plus 10, and we'll take the positive 10, and we'll put it on the other side of the equation. I'll just go back. 2x plus 10 equals 60. We take that positive 10, and we make it a negative 10 on the other side of the equation. Now we have 2x equals 50. We want to isolate the x on the left-hand side, so what we do is we divide the 2x by 2 so that we have just x, and then on the other side we divide the 50 by 2. X equals 50 over 2, and then it's just a simple case of dividing 50 by 2 to give us the final answer of x equals 25. And if we like to check, we can take this 25 and we can plug it back into the equation, and we'd see that 2 times 25 is 50, plus 10 is 60. 60 divided by 3 is indeed 20. So that's just a way of checking to make sure we have the right answer. Our next question is a little bit more challenging in that we have two fractions on the left side of the equation with different denominators. So the first thing we need to do is find a common denominator between 8 and 3. So we can start by listing the factors of 8. They are 8, 16, 24, 32, and so on. And then the factors of 3. 3, 6, 9, 12, 15, 18, 21, 24, and so on. And we can see that 24 is our common denominator. So we're going to use that, and we're going to rewrite the left-hand side of the equation with 24 as a denominator. Now, what did we have to do to this 8 to make it a 24? Well, we had to multiply it by 3. So we're going to do the same to the top. What did we have to do to this denominator 3 to make it a 24? We had to multiply it by 8. So we'll do that to the top. And we're given something that looks like this. 3 bracket x plus 3 over 24 plus 8 bracket x plus 1 over 24 equals 3. Now we have the problem of getting rid of that 24 in the denominator. And once again, to do that, all we need to do is multiply the entire left-hand side of the equation by 24. Once we do that, we have to also multiply the right-hand side by 24 to keep our equation balanced. So we have the following. Now we can cancel out our 24s on the left-hand side and be left with the following. 3x plus 3 plus 8 times x plus 1 equals 72. remember we had to multiply the right-hand side by 24 as well, which is how we got our 72. Now, what's left is to expand the left-hand side. 3 bracket x plus 3 will equal 3x plus 9 plus 8x plus 8 equals 72. At this point, we can collect our like terms. Our 3x and our 8x can be added together to give us 11x, and our 9 and our 8 can be added together to give us 17. So we get 11x plus 17 equals 72. We keep the variable on the left-hand side, and we take that positive 17 and we take it to the other side of the equation, so it becomes 11x equals 72 minus 17, which further reduces to 11x equals 55. At this point, we can divide both sides by 11. X equals 55 divided by 11, which further reduces to x with a value of 5. Our last question in these examples is as follows. Here we have a 3 in the denominator. And we want to get rid of the denominator to make our equation a little easier to solve. So we will multiply the left-hand side by 3 and get this, and multiply the right-hand side by 3 as well and get 3 bracket negative r. Now, this 3 and this 3 cancel out. However, we have to remember that this 3 must be multiplied by 5 as well. These do not cancel out. So our next line in the equation will look like this. We maintain our r plus 5, but we have the 15 because of this 3 times 5 section. And then 3 times negative r gives us negative 3r. We can collect like terms. We have 20 on the left-hand side, and this r, if we take over to the other side, gives us negative 4r. So this will be negative 3r minus r. This positive r becomes a minus r, and we're left with something like this. At which point we can flip them around so that our negative 4r becomes a 4r on the other side of the equation, and our positive 20 becomes a negative 20 on the right side of the equation, giving us the following. To isolate r, we divide both sides by 4, and then we get a final answer of negative 5. Hope these examples have helped you.